let me start with from the beginning, because obviously you're left with that car there, which I'm start fixing it, and I've done quite a lot. It's gonna be another video and I'm gonna working on that. I'm not gonna mix it the two in for now. So this one obviously is off the ramp. I've done quite a lot already. Where's the hunch? You see few lines, coolant lines already laid down where they're supposed to be. The water pump fixed with the proper mount. It isn't finished, obviously due to the clips. We have to get the correct ones as we run out of them. The oil cooler is off and all the stuff, blah blah blah. Underneath the car is all done. I got them routed properly, so under the car is pretty much job done. Remove all the wiring room, remove everything that had to be removed, cleaned, washed, everything is mint now, everything is clean. You not get dirty or filthy when touching stuff. Let me just put this somewhere here. Let's put it there. So yeah, we got the exhaust manifold up, obviously clean the subframe and everything. I don't know why they haven't painted it. We say we have to paint it, if not it's going to rust. Anyways, yeah, exhaust manifold is off, sump is off. I've just put the temporary and the old one temporarily on, so no water is going to go in because I steam cleaned it. Exhaust manifold is on. GT30 70, I don't know if this is 71 76, I think it's 71 is on. Cold intake is already on. I've done everything underneath there. Obviously remove all the crap that is not needed. Change that bracket, put the air filter in. This side is finished, it's done. That side still need to work on it because that's gonna be the oil cooler. Then I've got fuel lines still needs to be done, but the rest are off. Well, everything is off really. I finished it. We finished working on this Friday, kind of like late mornings, because there's a list of parts. We have to get all the stuff, and the weekend is coming. You know, nothing is gonna be in time. So it's like, well, I could do some small bits, but nothing important. And then obviously next week when all the stuff that we have to order arrives. Because I can't even close the engine, you see, I can't even put the sump on because we have to change the oil pump and all the stuff. So I said fuck it. And the rest of the day on Friday, I said I'm gonna start working on mine. So I move them around. As you can see, Steve's car is here as well. So I have to do the turbo. Actually, I'll show you. So as the turbo, exhaust housing. This was massive here. Steve chopped it off all with the angle grinder. Bits, and then I have to get it down, obviously machine it all down to that surface nice and clean, and then I made a mark to just behind the wheel. I have to do kind of like a transition to open up because this is going to be 4-inch, and this is, I think it's 3 or not even 3, something like that. So a nice smooth transition. Then I have to put a piece of a reducer or maybe straight V-band on, depending how much I can machine down there. It depends. Once I start working on it, it will show me how much space we have. But yeah, that's later. I removed Steve's splitter because this is essentially my splitter originally. When Steve was going to do race wars, I said, well, you don't want to do 200 plus miles an hour and not having any aerodynamics. It was like, I don't think it matters. Like, no, it fucking matters. At that speed the air density is high. So I said, you know what, fuck it, use my splitter. We just make a mount on your car and use that, and everything was fine. The problem is, if you go on the race was videos, like my videos about over a year ago, the latches, that latch on that, obviously this is bodgery that we've done after they broke. The same latches that people use successfully in the circuit for quite a long time, they hold 130, 140, 150, no problems, but this came off at about 175, 180, so we sort of found the limit. They broke and the splitter collapsed the front, on the ground, and this is what happened. This is upside down now, so you see how much is shaved off. That used to be 4 inches, and it's what, inch left in places. But the beauty is it actually didn't broke. It kind of collapsed here on this mount, kind of cracked there, but it was still in one piece. So it obviously broke down from 180 miles an hour, slowed down, and then about a mile and a half back in the pits all around. It says rough road, and this was hanging down. So I'm very happy with it. Obviously it doesn't look like this. As ribs, you can see ribs there, massive rib there, and ribs there, and that is the attachment on the back of the car, so it seals everything. It goes to obviously behind the wheels, where when you closing kind of like the bonnet area, so the air cannot go, whatever air is going to be trapped from the front can go under the car, so there's no lifting. So that's one thing, plus also creates lower pressure in the bottom. So yeah, it does a lot aerodynamically, and again, as you said, it was very stable, so I'm happy with this. I don't want to modify it. I've done a little bit of changes, very small ones, like the cutout here. I left another 2 inches here, don't need that much. These cutouts don't need it. I know I'm gonna be a little notch here, but not that big. This one I've done it quickly because we literally done it on a forklift. The car was lifted on a forklift, and I've done it there because again the next day we were going, so it was a bit of a rush job. But speed itself, the construction, the shape, mint, very good. So I've redone it. Obviously we're gonna use this as a template. I cut that off because this is gonna be used as a template for the shape of this, because this is actually the shape of the standard bumper. Because what you do with the bumper, this is actually flush, like completely straight. So I had like a string with the pendulum and run all around the car bumper, the shape, the profile, if you want to call it so, and that is exactly it. This is very important. So because then obviously you build whatever from there. So that is important to reproduce this shape, because this, you know, few cuts, because it's like a knife shaped. So this being so strong, this is extrusion, it has massive rigidity now. It won't flex left and right. As a matter of fact, there was another rib, you see that reinforcement there across, with that one in the middle, there was no flex. We both were hanging on this. It did not move 1 millimeter, well, maybe a millimeter, but no more than that. So really happy with this. Now my one, what I did, you see I left less space for the tires to work. Again, I need to check that correctly. If you still have enough space, enough clearance, obviously you have to jack the car up, because when the suspension decompresses, the wheel is going to go slightly lower and it may catch something. If it does, and I have to trim it, so a few refinements needs to be done, but I already reproduced it. So that's the splitter situation. I still have to do a lot. I have I think just enough material to finish mine. I'm gonna do, what is this shit? Like, what's in there? Because a bug, that was down because it was so sunny. There was a lot of sun coming in, very hot. It was down. I was chopping with the alley with it, so I got up and I banged it with my head like full strength and shaked. A lot of dust and shit came off straight on my head, on my neck, everywhere. Anyways, back on the topic. So now what I have to do, actually loosen them up already. They should come off actually now. I have to get the boost pipes off. Should be. Come on, there you go. Put them somewhere safe. So yeah, I have to redo these, bend them back in, and I have to start doing mounts for the diffuser. Quick mounts, quick disconnect mounts anyway. Still latches. This is the plates. These are the plates. This is the compound I got these latches from. Apparently good reviews. This is supposed to be strong enough. I've looked into the latches, because what broke with ours, it was this, the hook here, but the one we had, this was like half the size of that. So not mechanism itself didn't broke. This is like you pull it, can't remember which way, this way it opens, and then you push it down and it closes. So this pretty much opened up on the old one, completely like snapped in half and ripped everything off. The mechanism itself didn't open, it's just that hook there. So yeah, this is pretty much how it works. You have to mount this obviously with those plates like that, and those plates go, actually let me show you. So that goes there. Obviously has a pivot because you can change the angle, obviously if you rise on the bottom, on the front, or you got adjustments even here, the way you put it on the chassis. So you can, you know, change the angles, change the height, etc, etc. But I already know the height, I'm gonna fix it to be there roughly. I do still want to have a possibility of fixing it in a different place or different angles, but I know the basics now because I know it works. I don't like the fact that this is small. I'm probably gonna fix it on something wider because yeah, these are the ones that I made. You see, they're about twice the size. So doing that, the mount on the back, I may do 2 mounts on the chassis or one, I don't know, I have to make a decision. So attachments is still working on it. The one I've done on this 100% works. I just want to make sure that there's nothing better I can do. I'm 100% happy with that, don't take me wrong, but always, if I change something or do it again, I'm always looking for a bit more. There is a chance to do something better, yes, good, we do it. If not, we stay the same way. But there's always chance for improvements. So that's the speed situation. Now let me explain what I'm doing with the car. I'm trying to do the whole aero, and pretty much over this weekend. It's not going to happen obviously on the weekend. I don't have enough material, and explain what I need the materials for in a minute. Let me go step by step. If not, I'm going to lose everything, and it's going to be another video I have to edit, and I'm not going to have a time, never going to post it. So let me go through this. First of all, aero is a full flat floor. You're starting with everything flat under the car, yeah. And side skids, they have to go as wide as possible because you want as less air going in as physically possible. So the widest part on the front obviously is the tires. So these are flush with the front tires, as you can see. It's just kind of like triangulated alloy. I pushed it on the press because you got the press there, the bender. The problem is both sides done exactly the same. It's a bit of an annoyance. The press is quite old, and the knife that presses into the 90-degree V-shaped base is not ideal because it's quite old. And there's 2 places, which is one here and one here, where presses too much, it sticks out a little, so presses too much. And what it does, this didn't broke because there's too much angle and it snapped, because this is very soft alloy. You can mold this, you can bend it as much as you want. It just pressed it too much and, you know, snapped it. Same on the other side, 10 places. All I have to do is to run a bit of weld, and it's only these 2 places there because all this radius here is nice and smooth, didn't touch, it was fine. That's a bit of a downside, but again, nothing critical. Of course, it's gonna be looking a bit maybe shit, welded up here, welded up there, because it may looking like bulged or fixed. It's gonna be fixed, but don't care. It's a prototype, and if it's working, it's working. As you probably know by now that I really don't care the way it looks like. And I only do function. If it functions, then good, it stays this way. If it looks ugly, who cares? If it looks good, as a consequence, is a bonus. Then of course it's a good thing. But I never prioritize that, so I really don't care too much. This one is done. The other side is done too. Full length of the car. So slightly wider, slightly longer than the body itself. As you can see, this is a bit offsetted, but you see this is where this ends. This is going to be slightly more towards the back. Of course, there is air extraction from this area of the wheel. There's a lot to be done with extracting the air from the wheels. There's a lot of turbulences. You do canals, and then you do sort of air deflectors, because what they do, they deflect the outside and they generate low pressure on this side. It helps with the brakes ventilation, it helps to extract that air anyway, is one thing. Also on the back as well, this should be like from here, carried off and do like a ramp to extract the air out. I'm gonna have to work on that later on, but for now I just want a basic. So I will do something here, but not for now, not now. So the way they work, because it's triangulated, is very strong. But also I'm still debating on how to do the framing inside, because obviously you can't just leave it loose. This is 1.5 alloy, and if you see, it will flap around if you just bolt it and leave it like this. So this part all along don't need any reinforcement, but the bottom, because it goes from here to under the chassis, it does need sort of framing or support. Now we're gonna get into that in a minute, because there's so many options and my head was hurting yesterday. I sort of made my decision, I'm gonna explain in a minute. Now when we go to the back, actually you know what, I'm gonna go from that side because I can show you better. Actually I'll show you from underneath first. This is my splitter. It's got a small canard on the back, not canard, fuck me, gurney flap on the back. I explain why. Everything has a reason, and it goes pretty much half an inch between the tires, so half an inch space between that tire, half an inch between this one, so it results into, I think, about 120 centimeters width and 130 long. And 130, if you see where the broomstick is, which is a perfect size. I explain why. That broomstick on the top of the ramp, so the broomstick diameter and that piece there of the ramp together is exactly 3 inches, and 3 inches is exactly what I need to achieve as the height of the floor, the whole thing. Not exactly, because you want to slide on a slope and because the car is not going to go up on the back. I have the correct geometry on the back already, so it stays this way. I could actually lower it a tiny bit, maybe a degree or two on the back, but I'll leave it this way. I like the way it handles on the back, so it should be sliding on the slope. As a matter of fact, if you see, my car already slopes down a little. You see this line here? This is true line, this is straight line, and this on the back should be slightly higher, kind of like, well, more than that, but you know what I mean. So the back will have to be raised a little, following the chassis line, and that slope is gonna give me about, I think, about 10 to 15 millimeters difference between the front and the back. So on the back it's not gonna be 76, it's gonna be 86, maybe 90 height. Now, is this a lot? Is this not enough? It's quite a lot, because I'm not sure what I'm doing with the car, what trucks we're gonna use. You know, if I go lower, obviously it would be better, but my spring rates, I don't think is right for the full aero, which is a bit of a bollocks saying that, because it all depends. It all depends on speed, because speed creates your downforce, airflow. Now, the problem with that is, so for example, my aero starts working around 70 miles an hour already, it does something, not much, but does something. So let's, for example, the splitter generates 100 kilograms of downforce, making this stuff up just to explain, 100 kilograms of downforce at 100 miles an hour. So you'll be thinking, if it does 100 kilograms pressure at 100 miles an hour, at 200 miles an hour, it would do 200, right? Kilograms pressure. It's not. It would do pretty much 3 times that. So it doesn't add, it amplifies. Its aero is a bit, is calculations a bit different. Again, I'm just explaining the basics, you know, the exact numbers, just roughly to make you understand how it works. So at 70 it works this way, and then twice the speed is about 3 times the downforce, or something like this. Obviously all depends what kind of downforce, what kind of flow you've designed, the angles and everything. It's quite complicated. So for example, when it comes to the spring rates, if you're doing this like cardwalk, for example, if I'm gonna do cardwalk, what are you gonna do? 100 average, maybe 90 average, and then when you go up the hill and on the top, on the back, maybe 130, maybe 140, you know, so speed's not gonna be that high. So I'm not gonna have that much downforce where I'm gonna have to be worried about my springs being too soft, because when you start putting 500 kilograms of downforce, make an example, so the car is gonna be squashing it down, because hey, if you put half a ton on the roof, theoretically, the car is gonna lower. Simple. If I'm going twice that speed, well, not twice, less than speed, but I say if I'm gonna generate a ton, 1 ton of downforce, and these springs are gonna go down quite a lot. Now what happens? This actually happened to Steve at nearly 200, well, at 200 pretty much. So what happens when you lower in the car, obviously on the springs, your flow, your splitter for example, is gonna go down. How much? Fuck knows. I don't know. You need telemetry, you need sensors, and you need to see it. You can put the cameras if you want to, but you need some sort of data. For now it's just pure guesswork, to be honest. Now my springs are quite harder than Steve's, but I don't think they hard enough for any sort of aero at any sort of speed above 110, 130. So yeah, up to there, I think again guesswork would be good. Also because my float is not too low. This is 3 inches, 4 fingers, so it's quite too high. I would prefer to have it slightly lower, but again, rough tracks, you know, you have to hit the curbs. It's all compromise. So I think 3 inches is alright, and at 130, this is not gonna go too low. I'm still gonna have enough space between the ground and the splitter. For example, if I do 200 miles an hour in days, I don't have a power for that, but if I did, there's a lot of downforce. A lot of downforce, like we're talking loads. This will lower. Now the problem comes, again, I was explaining what happened to Steve as well, with the softer springs, which amplifies the issue. You're already squashing the car down because of the downforce. When you're braking, the front dives. When your front dives, for example, it dives 20 millimeters on the springs, but because that's your axis, it pivots down there 20 mil. The back goes down up a little because Steve obviously had no diffuser, no area whatsoever on the back, so the back was fairly light. So therefore, when you transfer the weight, the front squats, the back rises up, you're making a pivot, so the front maybe came down to pivots to 30 millimeters down. Also removed about another 30 millimeters because of the downforce. Make an example, it went down 60 millimeters, and his flow was slightly lower because he was attached fairly similar, but his car is lower. What it did then, the front splitter just on the braking touched the floor, the ground, tarmac. What happened then, because that's your knife on the tarmac, there is no airflow. No airflow, the downforce is not there. So Steve's obviously case wasn't as dramatic because he doesn't have the whole flow, flat flow, anything. It's just the splitter, but even that stopped working. So you see what I'm getting? It's quite complicated. You have to do it proper. So what I'm doing now, I'm doing basics. There's a lot of things to add. There's a lot of small things that actually make a difference, but they kind of like refined adjustments. They do make a big difference, but they're very refined. You need the data. You need more data to work with. I don't have it, especially now. So partially because of that, and partially because I want to do the basics, and then, you know, I don't want to build everything too complicated, because if something doesn't work, I don't know exactly which part. So I'm doing basics only. And when you stick with the basics, it's very simple. So first of all, the floor as wide as the car, as the wheels. Great. This is 178, 175 with the floor, because on the back I'm actually 180. Over 180, 185 I think. 184, something like that. So quite safe. Obviously back tires are wider, but I'm not having obviously this wide on the front tires. Yes, you could change the shape so it gradually goes wide on the back. Don't care. It's what, 20 millimeters, 30. It's fine. It's fine. I'm just gonna keep everything simple because this has to be reproduced in an easy way if I have to. It's still consumable. The front, you can, if you're doing track days, you can do whatever. You can do 30 centimeters forward if you want to. I mean, it's open. Who cares? But I don't know what I'm gonna do with the car. So by the regulations, I'm sticking with sort of majority of races, regulations, blue book, etc., which it says 4 inches, 100 millimeters. So I'm staying 95 because we know how the scrutineers work, how the marshals work. We all thank them very much they're there. I don't know why, because we pay for that. And for example, if you go Castor Cube, Jesus, they moaning about everything. They're paying us more than anywhere else in the world probably. So, fuck it, 5 mil less. If I'm allowed 100 mil, I'm doing 95. So if someone's gonna moan about it, no problem, stays with 100 quid, raise the issue, measure it properly, it's 95. Same on the back. So that's the rule. 100 mil from front of the bumper, you know, where your edge is, that's 100 mil. Now the other basic, very simple, midsection, everything is nice and flat, no sharp edges, you know, the whole thing. And then obviously the diffuser to make it safe, you don't want to exceed about 13-14 degree. 15 degree is top, is maximum. You want it to be gradual because some people just mount like flat floor and then sharp angle and you go 13-14 degree. 15 top, I wouldn't even go 15 that far if it's like sharp. Again, depending what sort of, you know, how long is, blah blah blah, etc. And then the beauty of the MR2, there is actually quite a lot of space between the axle and those 4 inches, which is actually, this can stick out more. As you can see, this is not 4 inches, it's not 100 mil. I can bring it back more, so this is going to be even better than it looks now. You have plenty of space, it's quite lengthy. If you got a short amount of space, for example, mini finishes pretty much here. So if you go 100 mil from the back of the bumper here, it's very short and you don't have space under the, you know, the subframe, whatever. So it has to be quite aggressive. Being so aggressive can be long, you can't generate so much downforce. They chatty to the alley. When I'm chatting, they chatting. When I'm quiet, they quiet. Go figure. They're thinking I'm probably they're thinking I'm talking to them or something. I don't know. Anyways, so that's the basics. Now the beauty is, the best is to make the diffuser on the back as smooth as possible. So the transition from flat to the corner and exit on the ramp, that's the gunny flap. It's just quite important, I'll explain in a minute. As smooth as possible, so you're not going to have any separation, any obviously flow breakages, so separation. The beauty of it, if you see where the tire is, where the axle is there, where the broomstick is, this is very important measurement device. The corner starts, this is where we start rising it. You know, so it's very, I'm extremely happy with this, very good. Could you do better? Probably yes, it will need more extensive work. I'll probably have to remove one of the engine mounts on the back or shave it or make a custom one. To be honest with this, I'm really happy. I want to start with the basics. I don't want to invest too much time in this because there's going to be some adjustments, etc. So this is already way better than I thought it was going to be, because I thought we're going to start just behind the engine where the subframe starts, or just before the subframe. Instead, we're starting pretty much where the engine starts, actually before the engine, so nice and smooth. Partially this is possible because the car is not lowered. I've seen so many people lower these cars massively. Even Steve's car is a little bit too low. It still handles okay, it handles okay on the road, it handles okay in a straight line, because he races people in a straight line just on the road or events. He doesn't do circuit racing, so handling is important, but not as much as for me. So me, for example, if you see my arms, they're pointing down about a degree. So the height of my car is dictated purely by geometry. Roll center has to be correct, no matter what. So, and that's how it should be. So the weak point of this chassis is that you can't really lower them too much. That's why people, don't understand. They slam them down, they can't drive them. It's not obviously that bullshit, because the geometry is broken, they don't handle. And they are very sensitive actually on the geometry, so that has actually a big effect. So if you do it correctly, the car is actually not that low from the ground, which people thinking the lower the better, but again, it's not. But in this case, that is actually not a bad thing, because it allowed me obviously to have all the components fairly high up, not so low, to run obviously this curve here. Because you see that engine mount there? I'm probably gonna shave it a little bit because I want that slope to. I don't know actually. It looks good. It looks very good. I mean, that's just natural bend of the alloy, and the last bit here is nice and straight. I just really like it. So I'll probably shave it just so it doesn't, rub against it or flap against it or just, make any noises. But no, that's good. That's already good. I'm happy with this. So yeah, that it gives us enough space going, so I can go up where the sump is, I can go up where the subframe is, because it's not slammed on the ground. If this was slammed on the ground, I wouldn't have enough space to make all of this nice and smooth ramp. I will lose a lot of downforce from the rear diffuser. So it's not a weakness of these cars that you can't lower them too much, but if you call it a weakness, in this case, that's actually a strength. Is good. Now I'm gonna go up with the ramp. I'm gonna show you underneath, because important things happen underneath of the car in order to be able to run all of this. Because imagine by calculations that you're running about over 2 tons of downforce at about 200 miles an hour. Am I gonna do 200 miles an hour? Probably not. Probably being the key word here. Circuits, no, I'm not gonna have that power in. Donington straight, you're not gonna do 200. Silverstone, same, is no. I don't think so. But it's gonna be sustained. Now, for the moment, the original power-wise, right, I'll leave that at the end. Let's continue with the aero. So the aero has to be strong, because let's imagine that worst case scenario, right? Yeah, that's enough. So worst case scenario, let's exaggerate, because I like to oversize, over-engineer stuff. See the subframe, for example, or my arms, everything is just bigger than it's supposed to be. If I think this is enough, I make it slightly bigger. This is definitely enough, 100%. And when I'm gonna execute it, when I build stuff, I make it extra strong. So I know that part done. Like the arms I've done on mine. Obviously, you can't see them because obviously there's a diffuser now. But it's super strong. Yes, it's added some weight. Yes, it's not ideal for that because it's a sprung mass, blah blah. But in that case, a little bit of added weight gives me so much peace of mind, so I don't mind it. And again, it's lowered down, so it's fine. It's always a compromise. Now with the flat floor, it's exactly the same. If you imagine doing 200 miles an hour, and if you imagine, for example, your downforce is about 2 tons. 2 tons squeezes the car down. Now, theoretically, actually practically, if you would have a way to do it, you could switch, like alongside the wall. Hold on. Let's look it up, because lately there was one of the legs was dropping down continuously and was going twisting the car. So yeah, I'll lock it up. So what happens if 2 tons of downforce with a car that weighs a ton, if you put it upside down, obviously you have the gravity, you have the weight of the car itself, which is a ton, but you have 2 tons force minus the ton of the car weight, you got a ton. You still got 1,000 kilograms pushing you on the roof. So if you could run obviously on the ceiling, upside down, you will be able to do it. theoretic. Practically too, it's just how you gonna test it. It's like where's the ceiling, which is like a few miles long to do it. It doesn't exist, but that's the physics. But what that means, everything that is gonna hold your car, let's say upside down, because this is the simulation, all right, upside down, because you still gotta have that suction. The downforce is still active on your car at 200 miles an hour. If you're upside down or if you're on the ground, doesn't matter. It's there. It's pushing you, it's sucking you down from the floor, and it's pushing you from the top. Obviously, the shape of the car, the bonnet, the exit from the bonnet, the splitter, the diffuser, the rear wing, all of that. So all of these parts, imagine it will have to be so strong, even the flat floor, for example, if you could put like a suction cups all along your flat floor, let's imagine that for a moment, get the car upside down, and you should be able to lift that car from the suction cups from that mounted piece of alloy, you know, and plywood, whatever you're gonna use, and shake the car upside down and wouldn't move. Imagine that. So all the fixings, the way I fixed to the chassis, to the frame for the flat floor, all the basics have to be strong to support that. That's the way I'm doing this. So it has to be oversized, not oversized, but you know, stronger than I think I'm gonna need. But also we can't add, you know, 500 kilograms of steel just because we want that structure. So yeah, this is where the complications come from, and how to design, how to build the flat floor, especially the midsection, because the front, the diffuser, again, this is the diffuser. If you can see, you know what I mean, when the front bay finishes here, all of that is sealed, so there's no more air going down and pushing the car up. All the exits from here, but obviously here the flat floor continues, so there's nothing pushing the car up as the original M2. Actually, it's generating lower pressure. So the front diffuser is mounted on its own, it has its own mounts and everything, and obviously they have to be mounted on the chassis somehow, and then the rest of the floor has to be mounted somehow. Now this car there has that one has this nice frame or chassis bracing, which is very good, and it's nice and flat, and alloy is not too heavy. And I was thinking, you know what, I'm just gonna go cheapo, and just because I don't have the time, I get one of those, put on my car, and I use that as a base for my midsection flat floor. Well, they're available, but they're out of stock. You have to wait, God knows how long. I don't have the time. I have to do this before the end of this next weekend, so don't have much time. I have to work with what I have, so I have to make it. So now the dilemma was, do I make everything in alloy? Do I make everything in steel? So I've calculated the differences in materials, and if I go steel, the whole frame steel, I'm gonna gain 8 kilograms of difference if I use steel instead of alloy, because obviously even aluminium is gonna weigh something. Steel is just gonna be more, and the difference is about 8 kilograms, which is quite a lot. What I was thinking is to do like a cross member from here to here, because we're already gonna have one cross member to hold this in place, which I'm using. You have to look behind the broomstick. Using those because they bolted on the chassis like these. So there is a pipe that goes, tube that goes between them, weld them on, and these kind of clamps on the top. So imagine a pipe going in there, and these clamps on the top, the full length. So you slide on, you slide under the car, you slide it on top of the pipe, and then lift the front, click it into the latches. Very good, very easy to remove, practical, rigid, it works. Done it, is fabulous. Honestly, I don't think I could do any better. More refinements, but that's the structure, that's the way to do it. I'm 100% happy with that. Super strong. And again, that thing came off at 180. You had to slow down, then you had to come back from that. He says it's over a mile and it's rough road. Of course, it shaved a good portion, about 2-3 inches of because that obviously was there. I carried off of plywood, but the rest are almost intact. It definitely hits something strong here because it kind of like crack over here, so that nearly came off. Well, nearly not, it's far. Obviously I removed that one because I'm taking all of this apart, but it's still in one piece. So this done remarkably well, and this is 9mm and I'm using 12mm 9. Why I'm using 12mm instead of 9? I would like to tell you something technical, but the reality is just I thought I've done this in 12mm, so I bought 12mm both, and it's not, it's 9mm, so it's my fuck up. But to be honest, it's not a fuck up. I'm happy with the 12 because it's always a debate between using 9 or 12mm thickness for the phenolic plywood. This is called phenolic plywood. It's like compressed, very strong and very lightweight ply, as you can see. But there's a debate if using 9mm, which is lighter, or 12mm, which is slightly stronger. No big difference in weight, some difference in strength, blah blah. Is one or other is good. So if I had 9mm, I'll be moaning that I don't have a 12mm. Now I got a 12mm, I'm moaning that 9mm could be lighter, it's strong enough. You're not gonna win with me. It is what it is. Happy with the 12mm for now. Let's lock it that way. So that's done. So that's gonna have his own cross member, but obviously the midsection has to be super strong. So I'm gonna have another cross member. It's gonna go all along across there at the beginning there, because I need also a support for the side skids, and they need to be supported because this is obviously nice and floppy. So they're gonna have internal frame inside, no more than about 0.5 kilogram, very lightweight because I'm using extrusion aluminium, super strong, super rigid. Doesn't have to be bent, but that's not what we want it for. We want it to do for the rigidity, which is this stuff. This stuff here, not this. This is different grade. This was stuff here, super strong. So, and it very, very light. One of the lightest alloys you can get. So that's gonna be nice and rigid on its own, but I still have to support the whole lot. So it's gonna be, I think, one across over there at the beginning of the midsection and the side skids, and there's gonna be one when you see where the broomstick is at the end. It's gonna go all across. That's gonna be a support for the side skids and also for the midsection. However, because my diffuser starts, well, actually not here because it has to go further down there, it's gonna start roughly from here. So we're gonna have two. It's gonna have one where the broomstick is, where slightly move forward, another one here across all the way down, and then so imagine we have a cross member there, a cross member here, because this is behind the chassis legs. I can't close this completely because I have to be able to remove the fuel tank if I have to. So I'm gonna have to do some sort of like a legs going from this because it's nice and structurally strong. Sorry, going down, cross member, going down from the original cross member on the chassis behind the fuel tank. Can't show you because obviously, well, maybe you can see it there. Yeah, a cross member there, that's very strong, that's part of the chassis. From there, two legs, a cross member across, and then obviously the closer one is going to be this one, and between the back one, which is here, I'm trying to show everything on the camera as much as I can, and the one that is going to be on the front there where the broomstick is, do one cross. Now the cross section is going to provide a nice support for the midsection, because you know you can bolt it across and you can bolt it to whatever. I'm going to have attachments on the chassis legs. Now I can't bolt it directly to the chassis legs because they're not equal. This is a little bit of a step. There is a bolt there which I can remove obviously, but also there is a difference in height. So the side skids, because it's aluminium, is roughly going to be there. So you see there's a gap there, but the midsection, because I'm going to probably use for now to start with same phenolic plywood, because it's not big, it's not going to be much weight. 9mm obviously, because it has to be that strong. Plus again, I can run it thinner because there is a big support on the top. So yes, I'm going to spend some of the weight, because again, we're spending kilograms here. You know, you want to spend them as little as possible. If I spend them already, I'm going to use them for the support for the midsection to be strong. I'm not going to count on the midsection panel. Now, If I had the money, if I had a few grand to put honeycomb structure, aluminium honeycomb structure, nice and thick, that is solid, that is so rigid, you can have only a few fixings on the frame, strong, but not the reinforcement as a frame for the panel. It's structurally sound already. You could do it across, the whole thing. But that's at least about 2.5 grand just in material. And the flat floor, in my eyes, is kind of consumable because, hey, you hit a curb in the wrong way or something happens, you smash it. If I smash a plywood, which cost me 50, 100 quid, I can have another one the next weekend, put it on, no problem, it's not gonna cry. If I'm gonna smash 2.5 grand, material over the floor, yeah, I'm gonna be crying. So yeah, consumable. And the weight is like, yeah, but this is gonna weigh Todd, that's gonna weigh Todd. Yeah, well, the difference is actually not that huge. There is, but not that huge. And the problem is when you're bidding all of this, say for example, you're spending £1 grand, and then to reduce the weight by 20%, you're gonna have to spend additional 5 grand. So that's a big difference for a little gain. So the best part of all of this is to find a balance where you spend the least amount of money for the best possible outcome. This is, in my opinion, the best outcome the way I'm doing this, because you're not spending so much money, you're still spending a substantial amount of money just on the materials, obviously, but it's far away from carbon or honeycomb and all the stuff, because, and again, it's not just building the stuff, it's building and obviously living with it, servicing, like the engine conversion, same ideology. So when you're building stuff like this, at least me, I have to be very mindful about later on. For example, the splitter, great, works good, works great, it's structurally sound, it's broken, are we gonna cry about it? No problems, we use that as a template, on the service. Now Steve is gonna need a new one, so he's gonna have to get himself another plate, put this on, draw it around like I did, add whatever length he wants there as the lip going on the front, and again for that board there is enough space to have 4-inch 100mm. And just copy this, chop it off, put back on his fittings, because obviously these fixings here, I'll leave them for him, obviously I'll remove them just to have it as a template, but all these fixings you can keep them, obviously unbolt them, some of the stuff is riveted, so drew the rivets up like that. This is the lip, this is his lip, black one, mine is still unpainted, you see, so that's his stuff. So he's keeping all of that forever. So all the aluminium ribs and fixings and the frame, internal frames, for example, and attachment to the chassis stays with the car, stays with him. All he has to do is to change the bolt. Easy. How much they cost? Pennies. Bit of work, half a day, maybe a day, and job done. So it's a consumable, and you're not crying if you break it. So that's the ideology with everything. The diffuser on the back, side skids and everything. So that's what I'm doing. Now my debate was to do the steel kind of cross members and the support and the frame inside the chassis rails, chassis legs, this one's here, all across, because that will also do as a chassis stiffener. Now, so a lot of people put them on. I don't actually know if they do anything. This one is here for a reason. Maybe the tunnel opens up a little bit. Maybe the chassis may flex sideways tiny bit on the bottom somehow. I don't actually know. I'm not gonna go into that. Fuck it. If I'm spending again that material, I wanted to use it 100%. So I want that metal to use to function as a frame for the midsection, but also to stiffen the chassis. So if I'm gonna have, because this is gonna be about 11 kilograms of metal, of square sections. It's not a lot, but obviously we do a lot to remove 10 kilograms from the race car, so you're really careful with the weight. Every time you're saying a kilogram more, it's like, oof, I'd rather lose a kilogram than gain a horsepower. So that's the ideology. So it's a bit, but at least I know that, you know, I can stiffen the chassis. Whatever is needed or not, I don't know. And if it's needed, how much does it actually stiffen the chassis? I don't know. How are we gonna measure that? By the feel of my ass when I'm driving it. That's all there is. We have to be truthful about these things, you know. We don't have enough data. But at least I know is 10 kilograms spent in a good way. You know, I have achieved two things: stiffen the chassis, and I got the frame for the midsection floor super strong. I want to be able to literally jack the car up from my side skids, because and yeah, I can do it. I've done something very similar, more ugly, be more crude, on my S14, and it was working fabulous. And there were points on the side skids when I can literally just put the jack on and lift it up, no problems. Also on the Silver I had something different. I had holes here, one on the back, and there was a tube insert which was part of the chassis. And then when you jack the car up, you put like a Aureli stance, which is like a triangulation with a tube going inside. So yeah, that was, I never used them, but I had them. I've made them when I was making the flat floor. That car was fantastic. That was one of them where, you know, when you go in a corner and you start sliding, you know, you're losing grip. Instead of slowing down, what you have to do is just, you need more speed, because with more speed, obviously depending at what speed, not at 30, because aero doesn't work on 30, but you know, certain speeds, if you're going too fast, you slide in, it means you have to go faster, which, yeah, that is not always easy to comprehend, because instinct says, oh, I'm sliding, slow down. No, go faster, much faster. So you're going to have the downforce, the car is going to be pushed down, more grip on the tires, and you stop sliding. It's incredible, scary to at the beginning, really scary. But I think that's the difference between a race driver and a race driver. A difference between a race car and a proper race car, when, you know, you have to go faster to stop sliding around the corners. That is mind-bending. I mean, we see them on the What's going on? I'm super chatty today for some reason. I was saying, can't remember. Race car. You can have a normal M2, you can have a course, you can do whatever car. You put it in a circle, you sign for the race, and it's a race car, of course, because you're racing it. You know, and usually, you know, there is a fine balance between sliding the corners, you know, finding the grip, and too much, and you're sliding off. But with the proper race cars, with the proper aero, is the opposite. Of course, they have the limit too, but it's pretty much the opposite. So it's then when you see the balls of the drivers, you know, that's a proper, because becoming a race driver is peanuts. It's so easy. You know, you get yourself a license, which is ridiculously easy. Few questions, you know, flags and all the stuff, what you do on the circuits. You go on around this. They won't let me today. Maybe because it's weekend, I don't know. So we see them on the TV, you know, sometimes on boards. Oh God, they're so fast, but most people don't actually understand what is happening there. You know, how come they are so fast? It literally is the aero. So yeah, why I'm doing this, because well, that's another topic. Anyways, with the diffuser, like I say, it's very important, and this is, I'm super happy. It's gonna actually longer, because again, these sticks are about 2 inches. I want 4, so about another 3 fingers like that, or maybe 4, another 2 inches out. So it's gonna be even better. But I'm already super happy. You see where the wheel is, the axis, and that curve starts here, nice and smooth on that ramp, and the last part of the ramp nice and straight. Obviously I have to make walls, because you have to separate the airflow from because the tires, they generate a lot of turbulences, etc. So you want to keep separating that flow from the inside of the flow. Now when we're talking about that gurney flap, this one here, this is about 12 mil. almost facing straight up. There is another sort of a problem-ish I want to sort out, and I think majority of the cars with engines on the back, they have this, because all of this is going to be closed. There's no airflow, is just under the car, nice and stable, not interrupting anything, no turbulences, absolutely beautiful, low pressure, lot of suction, if you want to call it this way. I don't know what's the correct terminology, but what's happening now, we have built a shield for the sump and the gearbox, where the whole engine and the gearbox. That aluminium sump cools down the oil quite a lot when you're at speed, and same with the gearbox. Now we remove a good portion of the cooling force from removing obviously the air. I don't like it. Now the ways to deal with this, if you see the car, sometimes they have like a air inlets, direct the flow towards whatever they need to cool down. Sometimes it's a small radiator or oil cooler or whatever it is. In this car we just want to, you know, air to the engine bay itself to cool down the engine and the gearbox with air, and it's going to be sealed. And I kind of don't want to interrupt the flow with any air intakes inside, at least to start with, because I want to do the basics. I know I'm not going to go wrong. I mean, the way I've designed it here, this is perfect, because it's just baseline is by the books. This is where we start with. This is just the positive. There's no downsides of this, not single one, besides the weight, added weight. But aerodynamically, this is mint. When you do step forwards, when you start fucking about with it, be more, you know, changes and adding bits, then you could screw it up, you could do improvements, but it gets quite sketchy. You need a wind tunnel, or you need the simulations, or you need to scan everything 3D and, you know, all of the stuff. I don't have all of that, so basics for now is going to be fantastic. So what I'm planning to do, I don't know if I can execute this, because I need to close kind of like from the bumper a tunnel, and that tunnel, actually I'm going to show you on this car, it's going to be easier. This screws up, amazing. I love this. I think every motor should have it. So obviously this has the radiator for the charge cooler, have a big intercooler. So let's imagine this, the bumper starts here. I want to have a tunnel for the air to go through the radiators, through the obviously intercooler radiator, going up here, completely separated from inside this bay and going out of the bonnet. Pretty much here on the back of it. Side walls, top wall, everything. Not as this will be too steep. Mine is gonna be open, start opening about here and finishes there. Again, aerodynamic reasons. You know, you want to do as far back as possible. A little gurney flap, about even 5-10 mil will be enough to deflate the air and create a lower pressure on the bottom here, which is going to help to extract the air that goes there. Obviously it pushes from the front, goes out from here, but because you have higher pressure here, because again, imagine the air hitting here, is going to be some lower higher pressure. By putting the gurney here, you're going to create lower pressure, and then it's going to help with aerodynamics quite a lot. Actually, people don't think how much of an effect that has. And again, I've done it on my 14, and that was because my engine was where the radio used to be. So my S14 was exactly the same as this. There were no engine. My engine was starting there. My turbo was there behind, almost like at the height of the firewall. So I had this massive ramp. Obviously S14 is much longer of a car. I had massive ramp, nice and smooth, like a diffuser. I called it front diffuser, which obviously wrong way to call it, it's not, but you know, it had the same effect. So the front downforce on my 14 was incredible. It was awesome. I wanted to reproduce something similar to this. But then what happens, actually, I'm not gonna show you on this one. No, on this better. I've calculated, let me get it down a little. 1 I know this is getting long, but there's so much to cover. If you look here, yeah, once I got to the proper heights and everything, there is a bit of a gap. This is not the correct height, it's going to be slightly lower. I've calculated I have about 30 millimeters gap between the floor of the tuna I'm going to build and this, plus I can shave this if I need to a little. I don't want to shave it too much because again you want the air to hit the front here and it's going to pushing down on this, because the air that pushes down here has to hit the front first. Now the front obviously is going to go through, some of the air is going to hit this and push on the diffuser, because if the air doesn't push on the diffuser and the diffuser doesn't work on the top, it only works with the flow and the lower pressure here, but you want both sides. Also you can see the shape of this, you see it's kind of sharp on the top, which I can smooth it down a little, but this could be sharp and nice and smooth, kind of like rounded on the bottom. If you look at it, this is a shape of the wing which is upside down. So instead of creating turbulences like on this side, but you have a lot of air going here, so fights, doesn't matter with the turbulences here, but the air that's gonna go here is gonna be deflated but smooth. So what it's gonna do is gonna create a lower pressure on the hair. So what you're having is upside down wing, aeroplane wing, sort of, not exactly, but you know what I mean, the dynamics are very similar, and it's gonna pull this down, which again, this little thing, this little lip being this shape, it helps with the downforce. Every little thing helps. Now, going back to the gap, that gap is a 30 mil width of the intercooler, whatever, and I want to use that to kind of gain the airflow and throw it sort of guided between the flat floor and my actual body floor, because again the car is not slammed. I have quite a lot of space. I have about, I would say 2 inches in the lowest part. Obviously there's a tunnel, there's going to be turbulence, it's not going to be nice and flowy, but we don't care. All we want is we want some of the air going in there. Now that's going to obviously cool down everything. It's going to cool down my flow, my fuel, because this is the fuel tank, and again fuel, you don't want it too hot, the colder the better. So it's gonna cool down the gearbox and the sump, as you can see there. Now obviously the oil, we're gonna monitor how hot it goes, because obviously that's your gauges, but also have another temperature sensor to monitor how hot the gearbox oil goes, because I don't know, I'm not gonna guess it. I need data, so I need to accumulate some data. It may be really good or it may be really shit, and I may need a cooler. I don't know, we see. But again, I need to find out. Now, why is the gurney important on a diffuser? Because now, as I'm introducing some air inside the engine bay, that air will have to flow through the car. It means enters on the front, exits on the back. When it exits on the back is great, because obviously the drag behind the car, a lot of drag behind the car, helps to extract the air, because obviously there's a low pressure, turbulences, but extracting away, which is great because it helps with engine cooling, with the oil cooling, with everything, exhaust cooling, turbo cooling, because it gets quite hot in there. This actually have to be removed. I'm pretty sure I'm going to remove the whole thing, like the lot up here or something, I don't know. This area I want to open, so extracting the air out. The problem with that is that when you have air coming out from here and then you have air coming out from here at very low pressure, because that's what actually sucks the car down, you mix these two areas, and to avoid that you put a gurney. That gurney, what it's going to do is going to flow that air, it's going to go up a little, and this is going to also be kind of like suction on this side, and there's going to be separation. That separation, one way on this side, one way obviously pressure on this side, is going to create turbulences, kind of. Again, this is very poor language, but it's just the basics. It's going to create these turbulences here kind of up, and those turbulences, they're going to help to separate the two areas where it matters here. Without this, I'm going to lose this section here of suction downwards or downforce. Also, that ducktail is going to help a lot, again creating a lower pressure here. So again, yes, there's going to be a lot of drag, but also lower pressure here. You want as low pressure on the back here for the downforce for your diffuser to work. So even the wing, which is going to be quite a big wing on the top, even that wing helps the diffuser to work. So all of these things, they actually kind of work together. Again, this is only basics, so I'm not screwing up, because I'm doing pretty much by the books, the basics, you know. And again, the car is gonna be mentally good. Obviously, the difference is gonna be mentally huge between not having any aero to having full aero, even at the basic level. Now, usually the rule is that you don't exceed 12, 13 degree, 14 top when you're doing the split as the people usually do, which is on a straight angle, so you go flat floor, and then you can exit behind the subframe and you go up. If you do the transition like I did, very smoothly, so you start guiding that flow up and being smooth, there's going to be no separation, not going to break that flow. And because it's so long, you know, so nice and smooth, I've calculated, I've done some research, and apparently, because I have that gurney, because I have my ducktail, and again, a lot of drag, but a lot of turbulence, a lot of lower pressure there, and quite a lot of, again, lower pressure because of the wing is going to be mounted just behind the car at the same height of that. Apparently, that would allow me to run up to, safely, up to 18 degrees of ramp on the diffuser. 18 degrees is a quite aggressive area on the back. And apparently there shouldn't be any separation because I'm helping her with all of that stuff. And if that is true, which I'm hoping is true, because I don't have a professional simulation, but the basics ones, that would be good. That would be good. I'm using a lot of AI research. AI lies a lot of times, but if you cross-reference the information and every time they come back to the same results, I think it's quite credible. So I'm a little bit skeptical about it, but I've done like 4 or 5 different approaches and the results come up exactly the same. So quite comfortable to say that, yeah, it could be true. And I like it because I want the area to work at the lowest speeds possible, because this is the last bit I'm going to explain. And I'm going to shut off because this is too long. I know, I'm sorry. I'm running standard engine for now. So my engine is simple 1.8. I got a hybrid turbo because my original one blown, so I got a Chinese 130 quid special turbo, probably the shittiest you can get hybrid, but it boosts very quick. It holds the boost quite alright until it blows, obviously. Engine, obviously I've done the roads, but again I can't push more than usually we put in these engines with the basic swap, so it's going to be about 280 brakes, maybe, if the amount of fuel allows it, 300 maybe, raise the boost until we have enough fuel, because you don't want to run lean, I want to run a little bit rich, borderline, but not exceeding that. I could do some tricks, we could maybe run a bit of higher pressure on the fuel, we'll see, maybe 300 top, but again it's not great because these engines with the standard turbo, especially with the hybrid, the small exhaust housing, they choking the engine up on the top RPM. So I'm gonna be changing about 5-6 grand instead of 7.5, because there's no point to rev the tits out over there. If you have to get it, you know, shift, you know, just get on the limit and then go back because the corner arrives, then different story obviously. But that's technicalities on the track. So obviously all the aero adds drag, the front splitter adds drag, the diffuser adds drag, everything on the back adds drag. Now drag you compensate with power. If you have not much power, like I'm not gonna have much, then speeds are not gonna be that high. Acceleration is gonna be compromised. So I don't think I'm gonna reach, even on the longest circuits, higher speeds where I'm gonna need much stiffer springs, for example, and the area is not gonna be that functional. A sane person will say, okay, remove some of the downforce in favor of removing some of the drag. I don't care. If I'm losing 20 miles an hour top speed or whatever, or each corner, each straight, because of the downforce, I'll rather the downforce. I want to develop the chassis first, but test and set up the chassis with the aero first, and only then, when I'm happy with everything, we're gonna add power, because the engine has been built already. Well, I still have to finish the cylinder head. Turbo system is there already. Exhaust manifold is there already. Turbo is there. Plenum is there. The full exhaust, the screamer pipes, the wastegates. Once the engine is finished, the gearbox is built too. Long gear ratios, but the gear ratios, theoretically the car can do over 250 miles an hour, which obviously you're not going to do it, but that's the gear ratio. The power actually is going to be there to do way over 200 easily. So it's all there, but then I'm not fitting in now because we're already in mid-season and I have to do this. This is taking time. It's not a matter of just swapping the engine around, because I need fuel system upgrade, because I'm running 8 injectors, 2 fuel rails. We're gonna run race fuel or some mixtures we're gonna do. So the lines I'm having now, which is normal lines that we put in normal cars, like normal road cars that use normal fuel line, normal road fuel, pump fuel, sorry. They're okay, and I'm having the same, but they're not good for the race fuel. They have to be much more ethanol resistant. They are ethanol resistant. This is another thing. If you want to get a rubber pipes lines for the fuel that are ethanol resistant, because they exist, don't just go by because they say, oh, it's ethanol resistant. You have to go in the specifications and say what percentage of ethanol this is resistant to, because some of them are like 5% ethanol resistant and some of them 100% or 90% ethanol resistant, stuff like this. So you have to go deeper in, or ask them, because just because it says resistant, they don't say at what degree, usually what percentage. Good stuff, good companies, not just simple eBay ones, cheaper ones. Usually they have it stated, 50% ethanol resistance or something like this. So I will have to change it. The whole thing is a lot of money and it's a lot of time, which I don't have. I'm keeping all the money in the business. We're doing a lot of development. This is where the money goes from. This is the material I already have, and I don't want to spend too much on this. Especially time. Time at this point is more crucial and is more expensive than the actual money. So I really have to be careful how I'm spending that time. And I truly believe that it is better that I spend that time doing the full aero, develop, dial in the chassis, the suspension, the tires, brakes, where they're standard, so we know this shit now. Well, shit, they're okay, but for truck abuse, no. We need something bigger. But we're working on that, so I'm not going to spend money on something off the shelf for now, when I know we're already working on something that's going to be better than anything on the market from them. And it's going to be cheaper, so we're going to be using that. But again, even to test the brakes and the new hubs we're designing, I need the car to be mentally grippy and faster on the circuits, because we really have to put the brakes under heavy stress as much as we can. Hence 275 on the front, 305 on the back, as much downforce as I can do in-house without simulations, which is already I know is going to be loads. So we can put these brakes on the heavy testing. So when the brakes arrive, that's going to be Silverstone and Donington, because we want long straights, heavy braking with a lot of grip. So because when you lock the brakes, you have to lock the wheels, but if your limit of locking the wheels is very, very high, because you have a lot of tire and a lot of downforce to push the tire down, it's extremely difficult to lock it. So the brakes work more and you just slow down quicker. But there's a lot of stress on brakes. That's where we want to be. That's where we want to, test our bearings, our hubs, our arms, and everything, brakes and everything at the limit, as much as I physically can, obviously, because we don't have millions to spend on development. It's just me. So I'm doing what I can, and we're doing a lot already. So it has to be a balance. So I think I covered everything. I hope I covered everything. Now this one, I'm going to have a reinforcement, like another triangulation. I'm thinking to do another kind of like a wood that goes from there top to there, kind of triangulated, so it's going to be proper triangular. So lengthwise this is going to be super solid, super stable, nothing's going to be flapping, and then just some reinforcements, rib reinforcements between wherever that's going to end, probably roughly here, that kind of triangulated wall, and then the base, the rest of it, to attach it obviously to, because it's Jesus, it's quite low here, I can't show you. See, it's quite long, so from half of that length from the exit to here, there's going to be some rib reinforcement. Again, a lot of, I call it structural alloy, which is extrusion, super light, super strong. I have no problems to reinforcing that with very, very little added weight. This then is going to be attached here. I've bent this a little bit too much. I have to bend it back tiny bit to have a flush with the body. Hose, every, don't know how many, quite a lot of rib nuts in the body, and then just bolted on. This is going to be super, super, super strong. I'm probably going to put this, integrate this in my splitter on the front, but I've finished the structural phase. I want to mount it up. Today is Saturday. I have today and tomorrow to do as much as I can. I think I'm going to finish it today, because today I just need to finish the splitter, have it mounted with the new mounts. Maybe the side rods, I don't think I need them, because structure is so strong, I don't think I'm going to need them. Again, we'll see. Maybe these, I don't know, we'll see. If I have the space for them. I've calculated I have, that's why I bought them, but again, I need to check, because that's been over a year ago, I don't remember. And then I'm gonna have to calculate, well I already did, but do it again. Actually I have it here, some of this stuff, but I still need some aluminium bars and angles extruded. I need to make a list, I need to do all the measurements, everything I possibly need, and during the week everything has to arrive, so the next Friday or weekend I have all the materials to finish this. So the job for now is just the whole list, and then we're going to continue next weekend. During the week, obviously John's car, hope he's going to be finished if all the parts arrive, but it's all simple, so it should be. I see why not. The only thing is, now John is asking for the splitter, and although I have the template, no, I may do it in time. I may probably do it in time. If I squeeze everything next week, I have to get it finished by Friday, because I have to do the next car. I mean, that car is squeezed before the next car was booked in for a long time ago. I spoke with the customer, and he's like, yeah, I'm okay, I understand. I waited so long anyway, adding a few days, supposed to be 2-3 more days, and now it's a week. Even then he says, yeah, that's not a problem, a week longer, I waited so long, it doesn't make any difference. He understands the situation, but I just couldn't say no to that car, because it is what it is. It's a situation. Sometimes I do struggle to say no to people, but in that case it's the right thing to do. The only problem is the people behind in the list of the next car, they're gonna be moved back too, which is not ideal, because we don't have one customer waiting. Is behind that customer there's another, I don't even know, I think it's 4. Is that one the one that came from Italy? I think there's a guy coming down from Netherlands. There's another UK guy. I think it's 4 currently. Because I think I say to Steve, just stop booking people in. Like, okay, you gotta be the next, but I really cannot say when it's gonna be done, because this is changes so much. It's so unpredictable that I can't say to people, yeah, I'm gonna get you in 5 months time, because in those 5 months so much happening. There could be so many delays. I have no control of it, so I can't say anything. It's like, yeah, we do it, but when the time arrives, it's like, I'm sorry, this is it. I'm supposed to have a kid coming down to give me a hand with. It's supposed to be good mechanic, but yeah, I had these good mechanics before, and it's like, it's good and it's not good, and it's, with me, everything has to be my way. The quality of work has to be my quality of work. If not, it's unacceptable. That's why people bring the cars over here, because they see my work. I'm not saying my work is the best in the world. I'll never say that. I'm not saying this, but this is the way I work. I've been working on the race cars in fabrication all my life, and I'm nearly 50 now. I've built so many race cars. I know how to say this. I know what it needs to be done. I know the issues. I know how to prevent the problems and issues. Hence, obviously, now I build the swap kit and everything in the future. So, obviously, people who says, I want you to build my car, they do it. They say it because they know the way I work and it suits them. So it's a deal. I like the way you work. I want that kind of job on my car. So whoever works for me has to do what I do, because that's what the customer pays for. I can't just get the car in and then let someone else do it. That was the idea, if that someone worked the same way I do, which it did to start with, and then sort of degraded very quickly. So it's like, shit. Off the topic, I apologize once again. Anyways, a lot of stuff to do on the car. I'm hoping to get it finished by the end of the next weekend. That's the plan. We know plans don't survive the real world, so we'll see. Now I'm gonna get the camera off. We're gonna finish that and end of this video here, because it's 81 minutes. I'm not gonna edit it. I'm gonna put it as it is. This is mentally long. I apologize for that. But there's so much stuff to cover. I'm very geeky about this stuff. I could say less things, but I couldn't. And I've missed so much. Fuck it, I keep it to myself, because if not, it's gonna be 3 hours. That's enough. I hope you liked it. If not, there's nothing I can do. It's not finished yet, obviously. I have ramps to add on each side of obviously on the sides, before they're kind of like on the side of the wheel, on the tire. There is obviously a mount on the back there, and another rib or two, maybe a V shape in the middle. So far, it's 6 o'clock. I've started doing this yesterday. Yesterday about lunchtime, so today is 6 already. Is it 6? I think it's actually later than 6. No, it's 6:08. So yeah, I started this morning fairly early, so it's at least a day and a half comfortably, I would say 2. Actually, yeah, to get it finished, it's full 2 days work. So this is kind of like a labor we're expecting to make a front splitter only. But this also is with the mounts welded into the chassis, because I made a plate behind this, slightly bigger than that, 8 bolts, counter nuts welded inside, greased, stainless bolts, stainless nuts, and it's welded into this frame here, both sides. Now, there could be an argument that you could make it stronger by fitting these ramps, these plates on the chassis legs. Now, vertically there will be no improvement, they will be as strong. They could easily move sideways, yes, but if you put something straight here, it could move sideways. If I put this here, I would not have a space for my boost pipes, both sides, so it suits me better there. And plus, just remember, if you hit something with a splitter strong, like, you know, you're off. And if my splitter has to move something, I would rather to move these things, which is very soft. I can replace them, I can bend them, I can rebuild them, but not my chassis legs. Chassis legs, I would rather them being safe. So there's always a crush point, there's always a weak point where stuff is gonna go wrong, and something is gonna absorb, obviously the crash, the shock or whatever. I would rather these. That being said, these are very wide, you know, with that plate inside, they're very strong. I mean, I don't see these moving with ease, not at all. Obviously, once the back is done, that keeps everything in line. So when it slides in place and square. So you just push it in. That's what I've done, obviously, with that one. Push it in, so it can't go any further, and then clamp on. Because that obviously is a guide for these to be exactly in place. Perfect. Tiny bit inside. Tiny bit inside. Let's see if I remove it. If it slides in. There you go. I've got space for my boot spikes because this is, oh fuck off. Fly. This is here. This is here. All goes around. So you pull that and it obviously disengages. You can have cables from this side or that side or whatever. There you go. There you go. But obviously it pivots because there's no mount on the back. You know, but yeah. Splitter on, can't believe it. Full 2 days. It's all the work. Well, no one says it's gonna be easy. Well, it's not difficult. It doesn't move sideways. There's no movement. It's just perfect. Yeah. Then we have the sides to do. The big. Now I'll show you how big they are once they're off. See? This goes from the side of the car to under the chassis legs, but not over the chassis legs. So yeah, but it's very light. This is not heavy, so that's good. But you see how floppy it is? You can't just leave it like that. You have to make a frame inside, like a triangulated, stop it from flopping around. And that's it. I need to go. Well, now I need to change the sensor in the menu first, the adaptation, and then I can go home. But I need to tidy up first. This is obviously can't leave this place like this. So, right, see you tomorrow. Tired. Can't even smile anymore.